Seve, how are you?
I'm good. I'm good. We're 20 days into 2025. What's happened? What's happened so far? What's going on?
Well, the biggest thing for us over here at Atopile is we are so close to having replaced the core of our application. And as you know, this is basically a refactor of sorts. It's integrating an existing core, but it is still an enormous refactor.
Yeah.
And as I'm sure you know, with any enormous refactor comes an inordinate number of bugs and regressions and changes and diffs. And we are so close to the end of that. But boy, is it rough.
There's Atto code in the wild. So what happens to that Atto code in the wild? Are you saying like, hey, you guys are gonna have to upgrade, or is it gonna be okay?
For this 0.3 release, it's gonna be okay. We're going for zero diff, zero regressions. We'll probably go for pure extension for a little bit longer, like without making breaking changes. But there are obvious breaking changes in the future where you deprecate language features or you decide all sorts of things that we
just learn things over time. You know what I mean? I had somebody approach me today on Discord talking about they had a camper van and they wanted to do sort of a camper van style schematic diagram.
Okay.
And I was like, yeah, we don't really do that. We do like your traditional like KiCad schematic diagrams. But here, let me see if I can pull this up because it's really interesting what these camper van schematics look like. I'm curious.
It's like a wiring diagram for a vehicle kind of thing.
Yeah, exactly. It's like so for camper vans they have all here it is. So for camper vans they have all these subsystems, right?
Yep.
And a couple companies make these, and you basically have to connect these boxes together. You can see it's got like RJ10 and all that, all, these big power cables.
Yeah. To carry 6 volts at 100 amps for some ungodly reason.
Exactly. So I was like, yeah, we don't do that. But it's interesting because it's kind of similar.
Yep.
Just a higher level. Just go one more level up.
Yeah. It looks similar, which is actually a trap. Looks similar is one of the most common traps we come across, at least.
Really? Have you had another problem that you were like, this seems kind of similar, but we're not going to go there?
I mean, even if you go on the schematics versus like a flow diagram, which basically that is, right? So we in point 2 have a viewer, is like what it's called as an application. Yeah. You spool it up by just running a CLI command. It starts a web server, redirects you to a web page. And there's basically 2 tabs within that page. One, which is basically a flow diagram of all of the modules in your circuit. And like this one will take a signal in from this and then out to that type of thing. And, power from here to here type of thing. And that is not a schematic, importantly.
Right.
The schematic is a very specific pictorial representation that has been formalized and it's designed. But and there's best practice within a schematic that defines, you should have inputs on this side and outputs on that. High voltage power at the top and low voltage. Also, I say high voltage, I don't mean 400 volts. I mean the higher of the voltages at top and the lower at the bottom, which is typically your power and ground. But they can change. If you've got things going down the page, you'll continuously put them down the page. And so schematics are kind of their own unique art form.
Right.
And for a little while, we were playing with should they be the same thing? This flow diagram and the schematic, should we just generate one? Should we just do the other? And because they look so much the same, but they're not quite, and they're importantly not quite, it's not stop trying to fudge it.
You don't want to mix them. You don't want to necessarily have it be even called the same output. You want people to think about it with a different methodology.
Yes. Yeah. Yep, absolutely.
So what are these? So so there's the schematic, there's like this flow diagram. Is that what you guys call it? A flow diagram? This sort of version?
It's not like a super well publicized thing, but it's basically a flow diagram. Yeah.
And then there's also like these, what do you call it? Like the Fritzing style wiring diagrams, right? That make it really easy to plug things in. I feel like the camper van thing was closest to that. Yeah. It's really showing you how to wire things up.
Yeah.
What is that? What is that called? Wiring diagram, I guess?
Yeah, wiring diagram.
Yeah. And then, okay, so there's something that this camper van guy got me thinking of, and I'm curious what your take is on it.
Yep.
There's been some calls on Twitter to create a company that does automatic wiring harnesses. I think we might have talked about this before.
Yep.
And what does that look like if somebody wanted to build a company that kind of automatically put together wiring harnesses? I was like trying to think about this. I was like, is it like you plug in a bunch of cables to this kind of black box that's custom? Or
is it like literally? So are they asking for a service that has a simple like parametric API to order wiring harnesses.
I think that's it.
Okay, that sounds awesome. I mean, harness diagrams today are an absolute pain in the ass.
Is there a standard? Is there anything?
There are some standards, but the problem with them is that they're such this composite electrical mechanical thing simultaneously that when you design it, the software, you do a huge amount of the design in like your mechanical CAD software. And it's just 2D drawing package, right? You just sit there and like line by line drag and break this apart, this wiring harness that you've made apart, and write the tags of like, and you know, for the first 20 mil in, you want to have this type of tape, and then the next little bit you need to sleeve it in this way. You just like de-skin it and layer it in what may as well be PowerPoint. You know, it's like PowerPoint with a few dimensions to it, really. It's not far off it. Except that you're doing something that is so standardized and monotonous. And so there are specific drawing programs for it, but all they're ever been designed to make is a PDF. So you can send that PDF to a manufacturer, and the manufacturer would build the harnesses.
Right, and they kind of figure it out, and a human reviews it and stuff like that. So there really isn't a data format that's like, this is a parametric representation of a wire harness. It can do lots of stuff. That's probably going to be a big format, right? To support all the different variations of what a wire harness can be.
Yeah, totally. If you're going to do it in a like a super complete way, where you can, you can.
Oh, no worries. Do you have water, Matt?
Yeah, I know. I left my water bottle upstairs.
Oh no, we should pause. You can get some water.
Yeah.
Should we do a quick pause? Thank God for water. We don't appreciate water enough.
We do in my household. My girlfriend works for water conservation.
Oh, really?
At one of the local governments around here, and so
fair enough. Can't argue with it. Yeah, that'll give you an appreciation for water, seeing how we all ruin it all the time.
Oh yeah, ruin it all the time. I mean, I grew up in drought as well in Australia, so you kind of develop it like you get a 2-minute shower. That's what it is.
Yeah, I did not grow up in those circumstances. I grew up near Niagara Falls, and we were like, water. Actually, you know, you get a different appreciation for water because it provided a lot of electricity for us.
Yeah.
So
a lot of power. Water is power.
Water is power.
Very Mad Max of you, you know.
Also, Dune, maybe? Was that a Dune thing? Where they loved
That's true.
Water.
I mean, you kind of have to when you live on a desert planet like that. Boy, same as out here in California, practically.
Okay, so wire harnesses.
Wire harnesses.
What I'm curious about, what is the low-hanging fruit? If you wanted to do a parametric wire harness creation startup, you want to manufacture, maybe you want to hop on this made in America movement sort of thing.
Yeah.
What's the low-hanging fruit?
I think you could make a made in America wire harness online configurator, basically.
Yep.
That as long as it was easy to just sort of plop in and say like pin 1 goes here and pin 2 goes blah, blah, blah. Because what you do is you build this configurator. Almost immediately after that, you can get AI to just read a PDF and use the configurator on your customer's behalf. Right. And they just need to check it and they hit go. And then when you have whatever standardized format you end up with, basically out of that, what that configurator gives you is basically the ability to standardize the format and however you like, and send those instructions ideally to automated equipment to do most of that job before finally someone has to sit there and just poke in the last few wires. Because that's unfortunately
do the crimping and stuff like that. Yeah.
But all the ordering, stocking, making sure you have all the parts, knowing how much it's going to cost, all that type of stuff you could do. The one thing, unlike a bit of laser cutting, for example, where like Send Cut Send just absolutely excels, is that wire harnesses are largely still manual.
Yeah.
So you are, taking connector shell. Today, typically when you're doing this in a factory, you'll have an automated crimping machine. So you'll have a stripping machine in one. So you'll take a length of wire that's been measured out automatically. You take the end of it, you poke the end of it into an automatic stripper that'll like have an end stop to stop it at the right distance.
Nice. Yeah.
And then it takes the sheathing off the end of that wire, the coating. And then you poke it in another hole that slaps a terminal on it, crimps a terminal on it for you. And then you poke that into the right slot on the connector. Yeah. But you are still there as a person.
Yeah, because stringy things are hard for robots, right?
Stringy things are hard.
Yeah. That's so interesting. I wonder, there's got to be, maybe there's some kind of hack, That's why I'm like looking for the low hanging fruit. Like basically we've got my understanding of wire harnesses is we've got one box over here.
Yep.
It's got this wire output, and you just want to swap things around so it plugs in properly to this box. And
that's what flex circuit boards are for.
Yeah, see, that's what I was thinking is what if there was a black box in the middle that kind of did the swapping? You could put a custom PCB in there. Which makes me think camper vans are not a low-hanging fruit because of those massive power cables.
Yep.
You can't swap those on a PCB.
No, but I mean, they're also, all the boxes are everywhere. That's why you see in a modern vehicle, the consolidation of your circuit boards into really only a handful. Like I think there's 5 controllers in a Tesla left.
Yeah.
Like really not many.
Yeah.
And the data, well, the connectors between them are still fairly bust. But now in the Cybertruck, it's Ethernet plus power and not much else, you know. That's pretty cool, right? Because then all of a sudden you've only got a handful of cables, typically 2 from the twisted pair Ethernet. You don't typically use the ground as chassis in those circumstances. So you got a ground wire and a positive wire, 48 volt.
So there's kind of like a counter hypothesis here that maybe what's going to happen is instead of having tons of custom wiring harnesses, we're just going to have like more standardization of the cable, so you can just use RJ45. It's expected to be Ethernet, you know.
Ooh, see, not in mass production of products. Like I don't think so. No.
Everybody wants custom harnesses.
The thing is, like connectors and connecting are expensive and kind of bespoke to the application. Like if you need the sealing, it's well worth paying for on connectors, but it's actually really quite expensive. If you need a blind mate connector so that a robot can like blindly go in and it'll just kind of chunk into place, those are expensive. They're actually like quite expensive components in the whole total BOM cost or something. So you really want to remove those if you actually don't need them.
Yeah,
you know?
that makes sense.
And also, if you do over-standardize your connectors, you lose all of your poke-yoke ability, and so you'll actually end up plugging things into the wrong places because people that are doing the final assembly. So someone will grab the wrong leg of something and plug it in wrong, and all of a sudden you can't function.
Right, because you can plug in, if you can plug in a RJ45 anywhere, you're gonna plug in, you're gonna plug a router into itself and argue why is there no internet?
Yep, exactly. And so I think that actually the more integration onto fewer boards is absolutely a trend we'll keep saying. And that's one where flex circuit boards are incredibly interesting.
So flex circuit, I haven't used a flex circuit board.
Yep.
I'm very curious how flex circuit boards solve this problem. I imagine it can, I mean, it's kind of like a wire in some sense, right?
Yep.
So that's one thing. And then, I mean, can it carry like what other advantages does it have? I guess, is it being used for this problem today?
It is being used for this problem today. Let me find, okay, let me see if I can find internals of the Powerwall 3. Oh, yes, sir. I believe that is. Okay, so as we're looking over the top of this was one of the most beautiful circuit boards you've ever seen. So with a LFP Powerwall, you need to be able to get interface to each of the cells, each point on the stack, and to be able to ideally get heater power to it, you need to tap out a voltage from it to measure like what voltage each cell in the stack up is for the BMS's sake. And of course, you need to get actual power out of it. As well as get all of these signals all around the thing.
Yes.
And all of these cells are kind of like wonkily stacked back and forth.
How many cells are we talking about, by the way?
In the case of the PowerPack 3, I think it's something like 20. Yeah, something like that. It's not too many. It's not an insane number, but they're in like weird places, right?
Okay.
So your final control board is right up the top at a different level. And then what Narayan had designed, this is really cool, and his team, was a flex circuit board that sort of origamied up its way from the base and had 2 legs.
Oh, yeah.
That then origamied their way all the way along. And this is also really interesting, is you need, you don't think about things moving in real life because the cells swell and contract as over their charge cycles and their life cycles.
And
And so he's built flexures into this flex circuit board. And so as the things would swell and contract, is that the whole board would basically flex and move with them.
Yeah, this is a really cool area for flex PCBs. I'm trying to find an example, but I don't know if we talked about this, but there were these guys designing a PCB that you actually ate, you swallowed, and it goes into your intestine, and it has a camera, and it takes pictures of your intestine.
Yep.
And I was blown away by their PCB design. Very similar concept where the flex PCB folds on top of itself to create all these layers. And you can fit a lot more stuff on it, and you get this nice 3D shape. It all comes on one board. So that's true. That is a huge area for flex PCBs.
But in this case, you deleted the wire harnesses, so that's incredible. Like you get the density, but you get this wire harness deletion as well, because now all of a sudden your pack is assembled out of something that just sort of drapes over the top of it and taps into everywhere it needs to. As opposed to having to build a wire harness that bespokely, and this would have to be something that someone does is go by one and tap it onto the cell in the right place.
So true. Okay, so the TLDR, I guess, is wires help us move from weird places to other weird places
flexibly.
But flex PCBs also allow this. So we could actually just design flex PCBs to kind of drape over our circuit boards or connect our boards together.
Much of the time, honestly, like much of the time you can do this replacement. And you see it actually like in DSLR cameras, for example. If you pull an old one apart, they'll have like 4 or 5 boards in weird orientations that are all like wrapped together with this beautiful piece of origami, like flex circuit board.
That's so true. I was thinking, I was actually getting a little bit worried about this. I want to one of the projects that's like on my roadmap, which is like very difficult, is to like build something like a Steam Deck, like this little controller. Like, because building a computer motherboard would be very impressive. It would show a lot of capabilities, but who wants to build a computer motherboard nowadays? I want to build a Steam Deck. That'd be fun. And I get worried about the display and how all those things hook up in there, because the Steam Deck is actually a couple PCBs. Like each handle basically has its own PCB. And I'm really worried about fitting all that together. But no wires with the flex PCB. That's a great idea. I love that.
The other thing is, like, as soon as you start talking about like high-speed signals, then all of a sudden you need impedance matching on your connectors, for example.
That's right.
Whereas you can, assuming you design it properly, you can design it right into your flex PCB. And you put rigid stiffeners on sections of it as well. So you can actually laminate up what's basically a laminated rigid section, circuit board on sections of this, and you end up with what's called a rigid flex board. And it's this sort of like sprawling mess when it comes out of the factory. But if you design it right, a little origami, and hey presto, you have a finished product that's wrapped up in every orientation you need. It's incredible stuff.
That's so cool. So now you can do really, really tight impedance matching on what would previously been a wire that could easily go wrong.
Well, yeah. So you need to get a wire that's impedance matched and connectors that are impedance matched.
That's right.
And that's part of the reason as well that you can't use the same connector in every application. Because it just doesn't quite work.
Wow. Okay. Flex PCBs are not a gimmick. That's what I'm hearing. This is a very, very cool technology. Wow.
Historically, they've just been so hard to design. And it's really where the CAD tools get into it. Last time I designed one, I actually used the sheet metal tools in Fusion. And like, you're really shimming things in there. That's obviously not the right tool to be using. But
I love the sheet metal tools in Fusion. I just have so much fun. I've always been people like to CNC or 3D print. I've always been a sheet metal guy.
Really?
I love sheet metal designs. I think they're so fun to build. And then there's a couple places. Oshcut is the one I'm most familiar with. Not a sponsor, but Oshcut. But you can send them your sheet metal design and they create it for you, but they also have like a little viewer visualizer that will tell you if your geometry is kind of impossible, which is very easy to do for their machines, right?
Yes, that's pretty cool. Wait, and they'll do the bending for you?
They'll do the bending and everything.
Oh, that's incredible.
I love Oshcut. Very good prices.
Have you tried Sencut Send as well?
I haven't. Do they bend?
They do some bending, and they can do like stud installs and that type of thing as well, like threading holes and all sorts of little bits and pieces.
I love
like
that. Yeah.
So they go, they do a pretty damn fast job as well. I think their minimum spend is just like a flat $30 for any order.
Oh, that's great.
And so like whatever, you get like 4 or 5 parts, and it's just like meets that, and they're like, cool, no worries, free shipping. And you're like, oh my God, like this is incredible. It's going to be
amazing.
here when? A few days? Okay.
That's great. So is that, do you know where Sencut Send is
I believe
based?
it's Reno.
Really?
Yeah, so it's real close by too.
Damn, all right.
Or maybe like Sparks, I think.
That's pretty cool. But, Speaking of made in America, there you go.
Yeah.
There you go.
Yeah. Where's Oshcut done?
I don't know. Well. I'm gonna find out.
It
right
must
now.
be here as well. Really, it must.
I think it must be. I definitely know. Let's see. No, I just had their address. Spanish Fork, Utah. They're in Utah.
There you go. Also close by.
Incredible
stuff.
Yeah, love it. Speaking of connectors.
Hit me.
Dell has a new laptop where you can screw in different port connectors. Just screw them in,
Oh, okay.
solderless. This is what they look like.
This is interesting. Okay. This looks a lot like, God, what's that open source laptop? Do you know
The framework
framework?
laptop. Yeah,
The
and you can
framework.
replace everything. They must use something similar. I don't actually know how they connect. Do you know? Do you just screw it in with a framework? No, you plug it in.
You plug it in. It's even it's toolless, which is actually
Yeah.
even a step further. So they have a separate like their standard of connector on the inside, and they have this like actually sort of larger module. I guess not dissimilar to this Dell USB-C module,
Yeah.
but actually like larger and a standard size. It's kind of cool in this case. So is the premise of this that you can replace a damaged connector?
I think maybe you can customize it, like if you want HDMI versus DisplayPort, but it might be repair oriented. I'm
Yeah.
not sure. I'm not sure why Dell did this.
That'd be that'd be a good one. Because the thing is, I'm habitual about always unplugging all of the connectors on my devices when I start doing things with them.
Really?
Like I won't carry around stuff. I won't put it in a bag plugged in,
Yeah.
except on under special circumstances. But like wrap up all my cables properly, because as soon as you drop a machine or you bump it or you yank on the cable at a strange angle, you're just destroying that port.
Yeah, it's gone.
And without the ports, what's your computer? I know that it's like kind of
That
nuts. It's the
sucks.
$5
Yeah.
part, but it's the $5 part that kills your computer. Really.
Absolutely. You can get a $3,000 laptop, broken HDMI port. It's like, I don't really like this that much. This might be worth $1,000.
God, I've for ungodly reasons only have two USB-C ports. If I lost, God forbid, if I lost one, this thing's fucking useless.
Yep, absolutely. Absolutely.
Which, thank God, I do appreciate actually. I did notice on the latest generation of MacBooks that they have made the minimum number of USB-C ports back to 3.
That's good.
Thank God.
Thank goodness.
Come on, you're paying $2,500 for a laptop. You really expect it.
I have three. Thank goodness. Woo. And you know what? I use 3 a lot, so I know that's about the right number. I don't think I've ever needed 4. So
yeah. Well, that's what. See, it's under the circumstances, I'm willing to reach for an expander if I want like some 5% of the time. But I don't want to do that on like a semi-regular basis. That's
it's annoying. It's annoying. Have you ever used? I forget what laptops have this. I think maybe Lenovo, but they have connectors on the back.
Oh, okay. It's been a long time.
You put it in a stand, and all of a sudden you have like the world of like anything you could need because the stand has like all the ports on it.
Yeah.
I kind of like that design, but it didn't take off. Yeah, ThinkPads. I'm a big ThinkPad
the dock
fan.
on the ThinkPads. Oh, people know about those. So it's super interesting that there's a huge community of like all the super nerds who are like really hardcore into the compiler infrastructure and Tinkerer and our CTO. Like those guys love the ThinkPads.
Right.
It's awesome.
Yeah.
And like really it's funny because there's no Windows left. All of them are running some distro of Linux.
Yep.
Usually Arch, I've found.
Yeah.
Or like NixOS occasionally, that type of thing.
This is who I was. This is the person.
Oh, you were one of them.
I was a ThinkPad lifer, and then M1 came out, and M1 just like
blew you away.
It just blew me away. I mean, that speed was like so good, and now I'm part of the Mac ecosystem.
Yeah. I wonder. I sincerely hope that with LLMs now being the largest user of RAM, like projecting forward, likely to be the largest user of RAM, the absolute RAM amount on the base level MacBooks, I hope goes up by a huge margin and it gets a lot cheaper. Because I do end up using my 16 gig of RAM fairly frequently. And come on, guys, it's 2025. 8 gig of RAM is an absolute joke. Don't make that the upsell. If I need to upsell to go from 128 to 256 gig, okay, I'll give you some serious cash for that.
But,
let's get some numbers in there.
This might also, I'm speculating, but this might also be somewhat why Apple Intelligence is not very great right now. I don't know how much you've used it, but I think they like kind of have to play with that lowest denominator. If they're selling an 8 gigabyte MacBook, Apple Intelligence has to work,
Yeah. Does it? Okay, so that's an interesting one because if I remember, their model is that they will try do what they can with a small LLM locally, and then they'll send off the larger tasks to the larger one.
Oh, they are sending it off.
Well, I don't know if they are yet, but that's their plan.
Very interesting. That's a good idea though, because you just can't.
No.
You just can't like do it.
No, God,
no. In 16 gigs or whatever.
No, of course you can't. That doesn't make any sense. But you can run like a very small model locally that's highly responsive and doesn't, keeps all your data.
Probably can solve all those like granny issues on your PC. Like, hey, this display isn't connecting. Hopefully.
Have you tried turning it off and on again? Yeah. Ideally. And so, okay, so under those circumstances, though, does that mean that the smaller models of laptop run a smaller model of LLM? Or do they just have one that all of them run locally? And when you hit the 8 gig wall, even if you paid for the, 128 gig of RAM in your laptop, it'll still hit the same wall and send it off to the servers?
They have to. I would think in the future, they will split it up. You'll have Apple Intelligence, like AI1, AI2, AI3. You'll have tiers, and then you buy it, and then people actually will pay more for the laptop to get that. So they're not even paying for the specs; they're paying for that Apple Intelligence level 3, or something like that.
Yeah,
and of course that's better privacy too. So maybe you can still get the level 3 on your 8 gigabyte MacBook, but you're not gonna have your data all private. Completely private.
No, they'll sell that. I joked about that, but actually, have you seen DeepSeek? Have you seen the new DeepSeek?
DeepSeek R1.
DeepSeek R1.
Yeah, big deal. It's kind of, so my understanding of it, and this might be a little bit off, but it's doing very well, and it's kind of like O1 mini level, which is quite
O1
good.
mini specifically, not O1 proper.
I don't think, I have heard, let's check it.
So a quick TLDR, the DeepSeek models are a family of Chinese trained and owned open source models as well. So I believe that means that both the structure and the weights are available, but I haven't validated the full access to all of that myself.
So I have up the Aider coding leaderboards. This is the one I look at, and I believe this is the polyglot benchmark. So this is how I look at it. Test coding tasks across a couple languages, and that's what I care about the most. And you can see O1 is still kind of above it, according to Aider, but DeepSeek R1 has now dethroned Sonnet. And Sonnet was really fast. Even though O1 is better, I don't use O1 because it's so slow. So DeepSeek R1, my understanding is it's fairly fast. It still uses chain of thought, so it can be a little bit slower. Yeah. But it's fairly fast too, so it's a very big deal.
Yeah, and they can edit formats. Interesting, they edit with diff. Okay, so they do that too, but I noticed the percentage correct using edit format is actually higher with the DeepSeek R1 than it is with O1.
Yes.
And interestingly, wow, Sonnet blows them both out of the water with the edits, which is an interesting trade to see go backwards between the top 3.
Yes. So a lot of people have been talking about this on Twitter where chain of thought makes you worse at just straight up coding. Like just straight up like outputting the correct code snippet.
Yeah.
But it does enable you to do more complex tasks.
Interesting.
So there's this little bit of a trade-off. And we've even seen that like when we were using Devin, if Devin runs for too long, it goes down rabbit holes, it gets confused and stuff like that. So chain of thought can have a similar thing because it's doing so much, it's spending so much more time and it's thinking about things longer. Yeah. It can go to a pretty deep rabbit hole.
Yep. Yeah.
And maybe that's what you need to discover something. Yep. But
so I've been running Cursor on agent mode recently, and I think it's insane. I think it's so good. Yeah. You need to treat it as is one of the interesting things with these tools is there's not I need to learn how to use AI. It's like I need to learn how to use agent mode more effectively because it's different. You phrase things differently than when you're asking for a one-shot thing.
Right.
Right. And you think about the scalar problems differently when you're thinking about one-shot thing in the chat. And so, in Cursor with the agent mode, for example, I'll upfront give it intentional instructions and when you believe you're done, now execute blah 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 auto build in order to actually test the code, for example.
Right.
And it will remember that and start doing it repetitively and iteratively. And that's I think it's pretty cool.
It's a really big deal. Especially because like I felt like I was acting like an agent, or I still feel like I'm acting as an agent when I one shot with Sonnet. I'm like, okay, do this thing, and then I run the test and I run the build and all of this. So having it be able to reflect is a really big deal. But I haven't fully embraced agents yet.
Interesting. Okay, so that's not how you've been actually writing a lot of your code yourself, or
no, I have been. Maybe I need to embrace agents more, but I've been really just supplementing with cursor. So like I'm like, this function is kind of obvious. So I hit Command K and it writes the rest of the function. So I'm really mostly supplementing. Every once in a while, I have a hard algorithm I have to write, and I throw it to O1, and I learn a little bit, but usually it doesn't get it right. But usually I learn a little bit.
Yeah, interesting. Well, what I wonder about O3 coming, because I mean, O3
That's right.
It was O3 that passed some AGI metric.
I'm
trying to remember which AGI metric. Now, so if
Sam Altman also said O3 is not AGI. He tweeted that recently. He said, calm your expectations. O3 is not AGI.
Look, I know I'm absolutely no one next to Sam Altman, but guys, the computers can think, and like not just a little bit. They can think well. And so I think that it's a little fuzzy, neither here nor there. We might not be at AGI, we might be. I think we may as well be, and that the target's shifted. And it's much more interesting to go think about something bigger now because we're practically there.
Yeah.
And so the fact that we're practically there with O3 coming out around the corner is really bloody exciting.
Yeah.
And some open source models like DeepSeek nipping at the heels of that, including some iterative type things. I wonder how long it'll be before there's a DeepSeek R3 that can also do what we're presuming is maybe a branch and tree within the search space to try work out what its train of thought should be and coach itself through cognition.
Absolutely. I mean, it's going to be a really exciting year. Anthropic also is due for release. They were expecting to release something in 2024. It didn't happen.
Oh,
we haven't seen anything the new Opus. Well, I think we were waiting for a new Opus by 2024. I think that was their target, and we didn't get it. Opus is supposed to be their biggest model, their smartest model. It was. I don't know why there wasn't an Opus in connection with Sonnet 3.5, but Sonnet is a smaller model than Opus. So you're like, where's the big one? Where's the really, really smart one?
Yep.
So OpenAI around the corner. Anthropic, I think, kind of doesn't hype it up much. They just kind of release it.
Yep.
So it could happen any day now. Could have happened right now.
Yeah, we wouldn't know about it.
Yeah, we wouldn't know. But it's very exciting. I mean, the AI in 2025 is going to be crazy.
It's a crazy space to be in. It's a whole crazy field because I mean we're still looking at it like LLMs are really still like the premier technology in the space, but we know there is a litany of other ways that you can perceive and interact with the world, basically.
Yeah,
and we've proven that this is one really effective way of training a model to do useful things.
Yep.
But God, I'm sure there are others, and I cannot wait to see them.
Yep. 2025. It's gonna be amazing. Let's go. Anyway, Matt, I think that's pretty good bow tie on our first step. Are we doing two?
Oh, I think we should bow tie. No, yeah.
You want to bow tie?
I thought if you just walked off with confidence there, I think we'd be good to go. Thanks, Seve.
I should have just had confidence.
Yeah.
I saw your eager smile. I was like, "Oh, should I?"
I was like, "Because I've
got a rant. I got a rant. I could go on. You know, I've always got one in store."
Oh, okay. Well, we should save that for afterwards, should we? Thanks. See ya.